Hey, what's up guys? So this is part 2 in my series of videos on the Internet of Things. In the last video I introduced you to the ESP8266, which is a cheap $3 Wi-Fi module. And we covered all of the hardware connections, how to flash the firmware. I introduced you to the command set, so how to actually communicate with the module. And we even brushed lightly on how to parse data from the internet and bring it into your microcontroller. Well, in this video, we're going to talk all about the code, so how to get a project like this running, which is an Arduino board, an ESP8266, some 7-segment displays, and basically what we're doing is pulling down the high and low for the day, the total views on my YouTube channel, the total subscribers on my YouTube channel, and the current temperature. So I'm going to show you exactly how to pull data, public data, from the internet to your microcontroller. In future videos, we'll get into posting data from the micro to the internet. We'll talk about creating like a web interface eventually. And probably down the road, we'll get into node. Oh, right now it's actually updating. We'll talk about node to node communication. So having two ESP8266 modules communicate directly with each other. Okay, so let's get right into the code. Okay, so just before we get into the code, let's first set up the internet side of things so that when we communicate, we just get the data we care about. And to do this, I'm going to use ThingSpeak, which will go out, talk to the web page where the data is at, parse it out, and just return that data. So let's first start by going to the web page where the data is at. And for this example, I'm going to use my YouTube About page here. And I'm going to pull down the subscribers and views. So I want these two pieces of data to be returned down to the Arduino. Okay, so I'm using Google Chrome for this. So I can actually right click there, inspect element, and it'll show me the page source, where it's at in the page source. So there's the subscribers, and I could probably even find the views. There's the views. And what's cool about this is that I can right click here and copy the X path. So if we go back to the ThingSpeak page here, log in, let's go to apps, thing HTTP, and I've already got one set up here called YouTube. And I'm going to edit this. So you give it some name. They give you a key, which I'm going to regenerate after this video. The URL is this URL here, where the data is at, and then there's all kinds of other things. And I'm using HTTP version 1.0. I'm not sure if 1.1 would work or not, but for everything I've been doing so far, I've been using 1.0. Go all the way down here, and you see parse string. And here is where you would paste in that XPath. So I'm going to copy XPath there, and I'm going to paste that in right here, save it, okay? And then here's the link that you call from ThingSpeak that they generate for you. Copy that. Let's give it a test. Paste it right into your browser. Enter. And there it is. There's the data. 33,142 is the subscribers. Okay, but really what I want is both the subscribers and views. So you can see, I see the views here, and they're all under... Let's see if we can't find this. About stats here. Actually, if I scroll over, it'll kind of highlight it as you work through this. This is a nice thing about Google Chrome. So see, it's showing me that this is that entire box right there. So let's go ahead and get the XPath of that and paste that back in here. Let's edit this again. Okay, save it. And then we'll go back to this tab here and refresh it. Ah, there we go. So now we're getting the subscribers, we're getting the views, and we're getting this other thing. Join May 14th, 2009. I don't care about that. Now, the other thing you want to do here, though, is this is what's going to be returned when you call this link. And that's the link we're going to use from the Arduino. Okay, we're going to call that. That's where we're going to connect to with the ESP8266. So let's do this again and do an inspect element. We're just doing this to pull up the page source. So this is actually what's being returned down to the ESP8266. It would be nice if you just get this, but you're actually getting all this crap. So you're gonna get this little caret B thing here. You know, that's to tell the HTML that it's bold. You're gonna get all that. So this is actually when we read this back, when this is returned, we're gonna look for these two keywords here. You know, this B caret and then that caret and that / there. So then we know that our data is in between there, and then we know down here that our data is between these two. So it's the only two bold things on the page, so we can just use those as our two parse keywords, okay? So I just wanted to show you that now because once we get into the code, this will all make more sense. Okay, so, and this works for anything, any page you can go to where you have data on the page that you can see when you inspect the element, okay? So you can get, you know, the weather, you can get gas prices, you can get, you know, stock prices, you can get sports scores or whatever you want. So anyway, now we can actually jump into the code. Okay, so here's the code, and you might notice something different. I'm using tabs here for each of the functions, which helps navigate and jump around the code a little bit easier, okay? So when you download the zip file, from the description below, the zip file is going to contain separate .ini files for each one of these tabs, okay? So once you unzip that into where your Arduino sketches are, in that folder you will have separate .ini files, but when you go to the drop-down file sketchbook, you will see just one file, and you should see this here, if it is the same date when you download it. Okay, so anyway, let's jump right into it here. I'm using the software serial library to communicate to the ESP8266 on digital pins 4 and 5. And I talked about this last time, so make sure you go back and understand that. You've got the TX and RX right, you've got the 3.3 volt level shifting all set up right, because you will blow it up if you put 5 volts on one of those pins, okay? So make sure you've got all that set up. Here's where you put in your router's SSID and password. This is a constant variable in the system. Well, I shouldn't say variable. It's a constant car in the variable. Make sure you've got that. I didn't put my own in there in case there's some super genius hackers in there that could get into my network here. So, and then here are the URLs. Okay, this format is critical. So I've got one for YouTube and I've got one for the current temp. And I didn't get into how I'm parsing out the current temp, but it's the same exact process as what I just showed you with the YouTube data. So it's got to be get space, and then you just paste that whole link in there that they give you, and then space http:/1.0/r/n, and then double that, right? That's a carriage return and a new line feed twice. Okay, same thing for the current temp. Here's some modes too. The CW mode is the station mode. That's what I'm going to set it as. I haven't experimented with AP mode yet, so I'm just, for now, the CW mode of the ESP8266 is set to 1. The SIP MUX mode must be set to 1 if you're going to be doing TCP communication. So I have that one set to 1, and that does reset back to 0 when you reset or you cycle power. Okay, so then we set up the software serial port. Okay, all communication will be ESP8266, so ESP8266.print. All the functions that you see on these tabs are listed here. All of the variables used in this program are listed here. All of the keywords, these are used for parsing out data and checking to make sure that you got the right response back from the ESP8266 when you issue a command. Okay, here's the keywords I'm using for YouTube. Remember the bold letter and the caret. And then for current temp, it's a similar situation. And then we have the setup for the program. So we'll go in here and I set up the direction of the RX and TX. Start that off at 9600 bits per second. That's perfectly fine for this. And then we kick it off and do a listen, then begin the actual hardware serial port at 115.2. I just wanted to keep that one a little faster than the 9600. And then just give it 5 seconds here, a little delay. So basically this is so if you want to launch a serial monitor window, like on a reboot, it gives you some time to go and do that before it like jumps into the code and it starts doing stuff, and then all of a sudden you launch your serial monitor window and reset the Arduino, and then it's like, you know, maybe it was in the middle of doing something important. So that's why I've got that delay in there. Okay, and then we call this function setup ESP. So let's go there. Okay, here's the function. It does return a, maybe it doesn't return a 1. It could return a 1. It's a Boolean function here. So this could return a 1 or 0. So the first thing we do is print AT with a carriage return new line feed, and this should return OK. Okay, so then we do this if read until ESP keyword OK, which keyword OK is defined back here, right here, OK. That's what we expect back when we send AT. And this function, which I'll explain in a second, then you have to send the size of the keyword and then a delay or a timeout. Not a delay, it's a timeout. So when you go into this, when you go into read until, it's going to hang there for 5 seconds, at least, where it's going to wait there for 5 seconds. And if it doesn't hear anything within that 5 seconds, it'll jump out and fail. And it'll return a 0. That's why this is an if. So if this will return a 1 if you got it back, and it'll say, hey, we're good. Okay, and then this, which we'll talk about later, is the mode of the keyword check. Okay, so let's jump into this read until. Where is that? Read until ESP. Okay, so here's the function. I've got a little description here, but basically you feed it the keyword, you feed it the size of the keyword, and we're using that size of right here, size of, and then we feed it the timeout in milliseconds, and then the mode, which is either a 0 or 1. Okay, so we jump in here. Timeout start value is the milliseconds, so the current millisecond count. Some variables which we'll talk about, and then we take the key size that just came in and decrement 1 off of that, because when you do the size of, it does include the null character, so you get an extra count for what it really is. So if you did the size of OK, it would actually return 3. So I just shave 1 off of that, so now it is 2. Okay, so what we do here is we fill up a buffer. Okay, so it's going to return, let's just say it's returning all kinds of crap. Well, we know we're looking for OK. So we only need to keep a rolling buffer of 2 characters. So that's why we do this I is equal to 0 and less than the key size. Okay, and this guy is everything in here. And then we jump right in, and then we do this here. And this is like a lockstep control here of the serial port. So while the serial port is not available, so there's no data on the ESP8266, it'll just sit here. And then as soon as something comes in, bam, it jumps out of that. And then it goes and receives it in the first position in data in. And data in is our buffer. But let's say nothing does come in. And we're in here. And then it's checking the current millisecond count minus that timeout start value. And if that's ever greater than our timeout value, which was 5,000, then it'll just time out and return 0. And as soon as you do that return 0, bam, it snaps you out of this thing and returns a 0, and it would fail. So if you come back here, if that did happen, it would say this would be a 0, and then this would say ESP check failed. Okay? So let's get back here. But let's say we got data. It reads it into the first position there, I equals 0, and it keeps going. Mode equal to 1 is if we want to basically save everything that's coming down the port. And we'll talk about that later, and it's used for storing the parsed data in between 2 keywords. Okay, so this time we don't care about that, so we'll talk about it later. So it goes through and it stores two characters then in this, since we're looking for OK. And then it jumps out and goes into this while one loop, okay, a forever loop. And the first thing it does is it checks to see if the data that's in that buffer is equal to the keyword, okay? So in this case, it's OK. So I is equal to 0, I is less than the key size, go through it, and it's checking each position in the keyword 1. Where is keyword 1? Right there. Okay, so that's what came in. I just wanted to double check that. So if it does not equal the data in, which is the data in the position of the buffer, then break. Okay, so just get out of this. We already know when it jumps into this, if it doesn't equal it, then we know it doesn't match the keyword, so it breaks out of this for loop and continues on. But if it does equal it, and it gets all the way to the very end, key size -1, then we know that it's a complete perfect match of the data in. The keyword is a complete match to the data in, so we can, so that we can return a 1. So that would return a 1, so that's nice. So if it did receive OK, let's just say you sent this, and the first thing it sent was OK back, then this check here would return a 1, and we know that it's OK. But let's say it sends a whole bunch of data before that, then this would clearly not match because, we just filled the buffer up with some garbage before it actually sent OK. So we keep going through. So it would jump out of that, and then we roll the buffer, and that's what this little thing here does. So it starts at the first position and goes all the way to not the last character, but one right before the last character, and increments it, okay? And basically what you're doing is making the buffer equal to the next one in line, okay? So it's like rolling off the data and then leaving that very last character open, and we'll get to this in a second. It leaves that very last character, the actual position at key size here, to be the new data that comes in. Okay, so and you'll see that here in a second. So it jumps then into this same exact while, there's nothing in the serial, or nothing coming out of the ESP8266, and this keeps it in a nice lockstep. Same timeout thing, but if there is new data, then it stores it in key size -1. So whatever that data is then goes into that new position here, okay? So it's kind of cool. It rolls the data kind of through that buffer. Okay, and then again, if your mode is equal to 1, it will store everything in between. So and that's it. That's kind of the secret sauce to this program, actually, is the way that I'm able to check for keywords and parse data out from the return of the ESP8266. Okay, so let's keep going here. Okay, so the first thing we do is check it, and then we call this here serial dump. And basically this is hey, we found the keyword, so everything else that's coming in, just go ahead and get rid of. And that's what this does. It calls this, goes in, and just basically, as long as there's data available, just read it into temp and just get rid of it. Okay, it's not doing anything with it. Okay, and by the way, this data could be optimized for efficiency. It could be sped up. There's definitely some holes here, but right now it's in its very early stages, and I just kind of wanted to get this video out there. But I do feel that read until here could be optimized. In fact, it would be kind of cool if you could feed it more than one keyword to check for. And I'll show you an example of why that would be useful here in a second. Okay, so the next thing we do is reset the module. And the thing we're looking for here is keyword ready. And sometimes it's kind of weird. Different firmware versions return different keyword or different readies. Like one version returned a lowercase r instead of a capital R. So you got to watch out for that. That's why it's always useful before you actually jump into this is to just get a USB to serial module and just talk directly to the module and kind of play with the commands, kind of like I did in the last video before you have the code. It'll make debugging a whole lot easier. Okay, so if you get that back, we're good, dump it. Set the CW mode, so this we're going to set to 1. And you can see how I kind of split it out because you can set this to whatever you want from the main page here. So I had to split it out here. So it sets that to 1, carriage return new line feed, and it goes and looks for OK. This will likely fail because if you set it the first time, it will return OK. If you set it again and it already was set to that, it'll return no change. So this will fail. That's why I have the timeout here set to only 1 second. Okay, so that's one example where having 2 keywords fed into this function would help. Okay, so now we're ready to set the SSID. Okay, so we set it up, and we have to break it up here. The SSID, then the key, and then the carriage return new line feed, and you need these little quotes in there too. and the comma, and that's kind of what all this does to build that up. Okay, it's going to go look for OK. Notice that I changed the timeout to 10 seconds this time because it can take some time to connect to an SSID. Okay. And then after it does that, it will go and check for an IP address. And it will do this CIFSR. And again, I have 10 seconds because that can take some time too. It'll go do that. Now here's where things get interesting. So it's going to go look for the IP address, and it's looking for keyword RN. Okay, so which is it's different. It's not the OK because this will return the IP address. So RN is the carriage return new line feed. Where is it at? Right here. So as soon as I see a new line feed, I know that the next piece of data is the data that I want to grab. That is the IP address. And I actually store the IP address in memory here. Where is it at here? So IP address here, and I've got 16 characters to store that. And the way I do that here is I know that the next piece of data is the IP address. So I change the mode here to 1. And what that'll do then is go and get all the data until it hits the next carriage return, new line feed, but store everything in between. Okay, and that's what the mode does here. So now I've got the data, and now quickly what I want to do here in this loop is go and store that data into the IP address array. So I started at 1. And I started at 1 because I'm going to use the 0 position of this to store the length of the array. Okay, so I is equal to 1, less than or equal to the scratch data from the ESP. And this is the data that is stored when you go into this. We could probably just work through this. So when the mode is equal to 1, the scratch data from the ESP at the scratch length is 1, and this just keeps track of the length of the data stored in this scratch data from ESP array. Okay, and you can see it's just taking whatever is in data in, and then it's keeping track of the length in the 0 position of that array, scratch length, and then it just increments that. Okay. So this gets kind of confusing here, but basically what it's doing here is grabbing it less than or equal to the length of the data minus the size of that keyword, because mind you that this mode, when it's set to 1, it's not only storing all the data in between from the last where you left off, but it's also storing the data, the actual keyword data, which we don't want. We only want the data in between these two keywords. So what this does is it kind of shaves that off. And remember that the size of always returns an extra count, okay? So that's why when you subtract it, it's actually, say that keyword was okay, it would subtract 3. So that's why I add 1 here to it to compensate for that. And I do have an explanation here that gets into that a little bit. Okay, so once you do that, then you want to store the length of the IP address array. And I store that into position 0, and it's this, I basically just copied and pasted that right here, okay? And that would be the length of that array. All right, I know this is getting kind of crazy, but when you kind of work it out, and sometimes it helps to just write this out by hand using like an example keyword and like, okay, like a two character keyword or something, you know? Because actually I did forget this. And then at one point I actually accidentally did this, and then, which is a bad idea. So it took a little bit of screwing around with this to get that right. Which was funny because when I did this, it worked somehow. So anyway, so you get that, and then we want to print that off. So IP address is equal to, and then it just burns through the array. And this works great. And it'll actually print off the IP address. And it's important to do this because you might think like, oh, well, every IP address is going to have the same length. Well, if your IP address is 192.168.1.1, that's fine. But what about 1.1.10? Then suddenly your array just grew by 1 character. So you do need to do this. Okay, and this same kind of thing could be used to display all of the SSIDs in the area, all of the access points it sees in the area. I don't have that in this code, but it could be done. Okay, anyway, so you might notice here's the bracket for that, and here's the bracket for that. So if it doesn't even find that first carriage return, it'll fail out of this whole thing and it won't even do it. So you'll just get an IP address fail. Same thing with the second one, okay? SIPMUX, set to 1, waiting for OK, and that's the whole setup. That's it. Okay, so now we're ready to start communicating. I feel like this video is going to be a long one. All right, back to the code. Okay, the base. We're getting in the setup loop here. All right, setup was here. So we just did that. Now we're ready to get into the loop. And this is pretty easy. So get YouTube, get current temp. One of the drawbacks of ThingSpeak is that there's a limit on how often you can communicate. I think they have a limit of something like 12 seconds. So that's why I have these separators in here, 15 seconds. So let's get into get YouTube. Where is get YouTube? Get YouTube. Okay, so we get into this, and the first thing we do here is build up the payload. And the only thing we're doing here is basically taking this URL here and storing it into the payload. So we don't really need to get into that a whole lot. But down the road, when we have a URL, when we're storing data in the URL, where the URL is not always the same, we're going to need to use something like this. So basically, you have a counter that keeps track of the payload size itself. So if you're kind of building it up, you have to have a counter to keep track of where you're at in the payload, and then the size is just simply the total size of the payload array. And so you can see here that it's just going through at the size of that URL, of course, -1, and it just burns through it and stores everything in the payload here. So it's a payload size plus I, which would be 0, and the payload size is 0. So this could be simplified a whole lot for this example, but you'll see down the road when we start sending data back to the internet, we're going to send the data in the URL. So we're going to have to build up a real payload of information. So this comes in handy. Okay, so you can see that it's the URL YouTube of I. And it just builds the whole thing up. And then the payload size is the counter plus the payload size, because we were incrementing that the whole time. Okay, so if connect ESP is true, so now we need to jump into that. Let's go right to that. And this is where we actually connect to ThingSpeak. This is not when we go and request the data. This is just to connect to the ThingSpeak server. So let's go over to that tab. There's a lot going on here. And this does return a 1 or 0. So it'll go all the way through and it'll return a 0 return a 1 if it's successful. Okay, so it'll print off connecting. We'll do a SIP start on channel 0, TCP, api.thingspeak.com, on port 80, carriage return new line feed. If we get an OK back, then we know we're good. We'll go ahead and print connected. Then we're going to do a SIP send, and this is when on channel 0 with how many bytes we're going to send, which is the payload size we just built up. And then we're going to dump everything out that is in the buffer or whatever we just saw, and do a carriage return new line feed. I did this after this because I just want to make sure that everything's ready to go, because the next thing we're going to do is actually send the payload. Okay, so once you do that, once you send at.sipsend with the number of bytes you're going to send, you should get this caret back here. You should get that back. And if you get it back, then it's ready to send. So now you can actually send that whole payload, and you should get send OK back. Okay, and that's basically what I'm doing here. I have a little loop here for I equals 0 less than the payload size, and I'm just printing off the payload. Okay, and then I expect send OK to be returned, and if it came back, we're good. It was sent. So now we're in a position where we're waiting for the ESP8266 to return whatever that payload was trying to get. So remember when I showed you when we took that ThingSpeak link into the browser and it returned all that page source? All of that's going to now come back. Okay? And if we got a failure at any point in time, we would fail. Here here's the return 1. So as soon as that's sent, it'll give it a return 1, and we'll keep going through the code. Now, one thing I added in here is that if it can't even connect, if it can't even do this here, this SIP start, I just jump back into the setup. So this is kind of like some self-healing function a little bit, so that if it can't connect for whatever reason, it'll go back, restart the module, reset up the SSID, and sometimes this does happen. I've noticed even on cheaper routers, sometimes this happens every once in a while. Okay, so let's get back to get YouTube here. Okay, so we connected. So this is true. So now what we're going to do is just hang out and wait for our first keyword. Okay, and I have this labeled as HTML start B. So remember from when I showed you the page source, we're waiting for this here. And then we know that our, let's go back here. Then we know that the subscriber count is between that and then that next B, okay? So you see here that as soon as I see that, stop, and then do this, go look for the next B, but while you're doing that, store all the data. And that's what that mode 1 does. Okay, and then as soon as it does that, now this is where things get interesting. As soon as it does that, we've got the data. We've got the subscriber stored in Scratch data from. We have it stored in this array. So what we need to do is quickly get that out of Scratch data from, because our views are coming up next. So what I have here is a quick little for loop. Same thing as the IP address. Same exact thing where we're just simply grabbing it out, storing it into YouTube subs, and keeping the length of the YouTube subs in 0. Okay? So as soon as we do that, then we go and hang out and wait for the next keyword, which is the start of where the views are at. And then we store the data after we see that one. And then we do the same thing here and store all that away into the views. Now you've got your data, and it'll go down here. And now that you have your data, there's one more thing you have to wait for. After you have a successful communication to the ThingSpeak or any website or URL you're connecting to, the ESP8266, when it's complete, will return an unlink. You'll see an unlink. So what I've got here is just as soon as you got your data, just hang out and wait for that keyword, because you don't want to then reconnect to it on accident or do something else before it's actually unlinked. So that's why I have this in there, and it will wait for that, found data and disconnected, and then you can go ahead and just dump everything that was in the serial buffer. Okay? And then I print off the data that it just found. Now note that this is just the ASCII characters coming back, okay, that we're building up into an array. So in other words, you've got this number, you've got 32,000 something something something, but in this array you're going to have the comma, so you're going to have 32 comma, which is going to take up a character in this array. So if you're going to actually do something with this data, you need to strip out the commas, and you need to convert each one of those ASCII characters in the array into decimal numbers, combine them into one giant number. Okay, in this case, they would need to be like unsigned long integers. Okay, anyway, that's in another video, but this is just to get the data down. And this will show you then print out the YouTube subs and the YouTube views. Okay, so let's get back to where we were. Actually, that's it. That's all there is to it. Now, the next thing it does, let me go back here in the loop, is then it goes and gets the current temp. And literally, that's just a copy and paste from get YouTube. Except I changed the keywords out, and I'm only looking for one piece of data. I'm only looking for the current temp. And I'll leave all of this here for you so that you can go through that. But why don't we really quickly, I'm going to plug in one of these boards real quick, and let's watch this happen. So we'll launch the serial monitor window here, and let's see what happens. So right now it's in that 5-second timeout period. Okay, does a check okay, so we're good. Reset was okay. Look, we had a CW mode failed like I expected because it was already set. Checking for an IP address, we got it, we're good. The SIPMUX is set. connecting, connected, ready to send, sent, found data, and disconnected. There's the subscribers and views. So here's what I'm talking about. You're going to have a character in there that has the comma. And each one of these numbers in here are actually ASCII characters. So you need to go to an ASCII table and convert those into decimal numbers if you actually want to do something with them. Okay, so 15 seconds later, then it went and grabbed the current temp. Oof, getting cold out there. And that's it. That is part two of the Internet of Things series of videos. Next, we'll actually talk about how to get data to the internet. So maybe we'll talk about logging data to ThingSpeak, maybe SparkFun's data server, Adafruit's data server. We'll talk about sending text messages. We'll talk about sending emails, whatever. All kinds of cool stuff coming up. So that's part 2. Thanks for watching.